Okay, chapter 1, section 6, we're talking about two-dimensional figures, so shapes. Woohoo! The vocab word we're going to use is a polygon. Okay, polygon is a closed figure formed by a finite number of sides. Okay, so a countable number of sides. I'm sorry, a finite number of coplanar segments called sides. Okay. Each side has a common endpoint. Okay, they are non-collinear. And each side intersects exactly two other sides, but only at their endpoints. Okay, so for instance, these are all examples of what polygons are. These are not polygons. Okay, here, like this one, these are curves. Here we've got curves. Here these intersect. Okay, so anything that intersects, anything that is open, anything that's got a little extra hanging out here, those are not polygons. Okay, so it's anything that is closed and each side intersects two other sides at their endpoints. Okay. Those endpoints where they intersect, that's called a vertex or vertices. Okay, and when we name polygons, we just list the vertices in order, like adjacent vertices. Okay, so yeah, that's polygons in a nutshell. Okay, so the vertex of each angle is a vertex of the polygon, and again, they are named by those vertices. Okay. Now we can have convex and concave polygons. Okay, convex is probably what you're used to seeing. Concave polygons are any polygon that has kind of a cave that goes in. Okay, if we extend this side here, this part of that side is on the interior of the polygon, and so that's what makes a concave polygon. Is if we extend all of the sides, if any of those extensions are inside the polygon, that's a concave polygon. Okay. When we classify polygons, they are classified by their sides. Okay. Just like equilateral triangles have all three congruent sides, equilateral polygons mean that all sides are congruent. Okay. There's also equiangular polygons, which means all angles are congruent. Okay, so we can have equilateral only, we can have equiangular only. Okay, but a convex polygon that is both equilateral and equiangular is called a regular polygon. Okay, so technically an equilateral triangle is a regular polygon because all of its sides are the same and all of its angles are the same. Okay, so we're going to practice here. We've got 3 examples. Okay, this first one, these marks here indicate to me that this is an equilateral. All 1, 2, 3, 4, 5, 6 sides are the same. Okay. Couple things. These angles are not congruent. Okay. And this is a concave polygon. So it cannot be equiangular or regular. Okay. But we also can classify them by the number of sides here. And so I said that this had 6 sides. A 6-sided polygon is called a hexagon. Okay, so this is an equilateral hexagon. Okay, example 2 here, we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, 8 sides makes it an octagon. Okay, and if you notice, all 8 sides have the same congruency markings, so it is equilateral. All 8 angles have the same markings, which means it is also equiangular. Okay, and if it's both equilateral and equiangular, that means it's regular. So example 2 here is a regular octagon. All right, here we have 1, 2, 3, 4 sides, makes it a quadrilateral. Okay, and I see 1, 2, 3, 4 right angles. And since they're all congruent, that is going to be an equiangular quadrilateral. Okay, and later this chapter, we will actually talk about specifically what an equiangular quadrilateral is. Okay. Last thing, the perimeter of a polygon is the distance around. Okay, officially it is the sum of all side lengths. Okay, so first example here, I'm going to go ahead and say that side there is 3.2 and here is 2.1. So the sum of all side lengths, 3.2 plus 2.1 plus 3.2 plus 2.1 is 510.6 centimeters. So the perimeter of that rectangle there is 10.6 centimeters. Okay. Example 2 here. For perimeter, we don't care about what's on the inside. Okay. We only want to add what's on the outside, the length of those sides. So 9.5 plus 9.5 plus 10.2 is, I believe, 29.2 inches for the perimeter of that triangle. Okay. All right. Example number 3, word problems, everyone's favorite. The perimeter of a rectangle is 46 meters. Okay, so I know that my perimeter is 46 meters. The length is 5 more than the width. So if this is our width, our length here is 5 more than the width. Okay. And we know, right now we know rectangles, the opposite sides are the same length. Okay. So my perimeter then is represented by this expression here. W, the width, plus 5 more than the width, plus the width, plus 5 more than the width is 46. Okay, because that perimeter was given to us. We've got 1, 2, 3, 4 W's. 5 and 5 is 10. Okay, if I subtract 10, 4W is 36. Whoops, that's a Y. 4W is 36. When I divide both sides by 4, I get my width to be 9. Okay, but I want the dimensions, so I need both the length and the width. Okay, so since my length was my width plus 5, my length is 14. So 9 meters and 14 meters for the dimensions of the rectangle.